Okay. Just let me know that, guys. If are you able to see my screen, everyone?
Yes, bro.
Oh. All right. So as we discussed in the last session about the OSA model, like how it works, what are like, the major transactions happen over the layer. So we have taken an example about like if we are sending an email for the OSA model, like how the email get delivered. Right? So for that we have discussed that there are the several layers are there. We have like application layer that will be considered as an outlook while we are sending an email. To application layer, then it goes to the presentation layer, which is responsible for encoded encryptions. They do the comparisons of all headers. Then we have like the session need to be created. So they initiate the session connections with the sender receiver and between them they establish a connection. We have transport layer where the entire email flow is done without any error. They receive an acknowledgement for each packet, like when we are sending it. Then we have network layer, which is responsible for routing the entire email to the sender email server to the receiver email server. And then we have node to node transmission that happens by the MAC address. And then we have seen that the transmissions of a bit happens through the wireless signal. That can be considered as physical signal where it can divide or a radio wave and so on. On the recipient side, the data move from the cable to the user machines where the presentation layer will take care of decoding, decryptions, decompression the data. And finally, the Outlook is an application layer for the recipient where they display the message what the sender has sent it to the recipient. Correct? This is what we have discussed in the last session. Yes, everyone.
Yes, bro.
Okay. Now let's go ahead and discuss about the same thing, but in some more detail about these layers. Now, if I talk about the physical layer, what exactly? The physical layer is responsible for controlling the signaling and transferring the raw bits on the physical media. So these have a specifications. There's a variety of hardwares can be there. So that can be the cabling, connector, and trans receivers, NICs, network interface card. It can be the wireless radios or hubs. That will be considered as the physical layer, the physical devices. So the physical layer coordinate the functions required to carry out the bit stream with the physical medium. So as a sender and recipient, if we talk about it, so the data come from the data link layer to the physical layer as a sender, and the recipient, when it's receiving the data, it will go from physical layer to the data link. This layer is responsible for movement of individual bits from one hop to the next hop. This is how the transmissions happen. If we talk about the next layer, which is the data link layer. Data link layer packet with the higher data into the frames. So data link contain the source destination address, source and destination hardware address, the physical address. We have discussed that. Based on the MAC address, a common address which used for the transmissions. But this data link layer is divided with the two sub layers that is called as a logical link control and other is called as a media access control. The logical link control deal with the protocol, deal with the protocols, flow controls, error controls. It deals with actual control of media, like whenever we are sending. So logical link control is responsible for framing, addressing, error control, flow control. That happens. So if we'll see that the data transfer which this happens from network layer to the data link layer to the physical layer. At the recipient side, physical layer to the data link layer and data link layer to the network layer. This is how the data transmission will take place. This is what we have discussed already, right? Correct, everyone? Arfat, okay. Jayas, is it clear?
Yes, I'm okay.
Yeah. Now, we have the network layer. So if I talk about the network layer, is responsible for source to destination whenever delivering the packet. It across the multiple network links, as we know them for delivery purpose. The network layer ensures that each packet gets from its original to final destinations while we have been sending. So network layer ensures that all the packets will reaches to the destination with the shortest path and faster flow. So router are the network device that operate at the layer 3 or the OSI model, as we can see that. So router is a res- primary responsibility to facilitate the communication between the networks. So these network layer is responsible for delivery of individual packets from source host to the destination host where people sit. So if we'll see in a very simple way, we have the PDU is called as a packet when we are talking about it, the network. So responsible for addressing the network devices, populating the routing tables, right? And also queuing the incoming and outgoing data and forwarding them according to the quality of service, the constraint for those packets. Queuing incoming and outgoing data. Now, what do you mean by that? Queuing incoming and outgoing data and forwarding them according to the quality of services. So let me ask you one simple question here. Let's imagine that there are the two users. One user is there on YouTube doing the live streaming. The other person is sending an email. So according to the network layer, which user have the more priority? The person who's sending an email or the person who was there on the like on the YouTube doing the live stream? I repeat the question. Guys, let's imagine a situation. There is the two user. One user is sending is there on sending an email. Another user is on the YouTube doing live streaming. So according to the network, which layer must have the more priority for data delivery?
Streaming, live streaming.
Live streaming. Okay. What about others' opinion?
So live streaming.
Obviously, the real time and live streaming have the more priority than the email, right? It's similar like if we are doing this communication, we are doing this Zoom meeting, it's a live meeting, right? So if anything, let's imagine a situation. If we'll say that this meeting we are while doing this meeting, if suppose let's take an example, there is a half second break, 500 millisecond break is getting between our communication, right? Or it can be a less than that. So is that, do you think like our communications will happen smoothly? No, not at all. Even half second or 1 second is not expectable because it will make it lot of difference while we are doing the live meeting here. But if I'm sending an email, if it is reaches you 10-second delay, it doesn't make any difference. Correct? Yes or no? Are you agree with me, guys? Everyone?
Yes, I'm agree with you.
So this is how it happens. Now, as we can see that whenever we're talking about that, that's the reason it says that the queuing the incoming and outgoing data and forwarding them according to the quality of service constraint set for those packets. Interworking between the two different subnets deliver packet to the destination with the best efforts. And it's provide the connectionless or connection oriented mechanism systems. Now, what does it mean by that? The connection oriented or connectionless mechanism system is nothing but the packet deliver can be happens. Either it can be the TCP or UDP, correct? So when I say the TCP packet is called as a connection oriented, when we are talking about the connectionless mechanism system, it's called as UDP here. So we have the TCP and UDP for the packet delivery here, which can be get sent it. So we can see that how does the packet is transferred and what are the things happens in the TCP and UDP in detail. Okay. So now, as we know, like network addressing. So it's a unicast, multicast, broadcast, anycast. It can be anything. So unicast is destination to the one host. Then when we talk about the multicast, it can be considered the destination to the group, broadcast to all, and anycast is the nearest one when it is sending it. So those are the routing address can be there. Now, if I talk about the transport layer, the transport layer offer peer-to-peer and end-to-end connections between the two processes on the same remote port. So this is communicate fall under the two categories, that is the connection-oriented and connection-less mechanism system. So when I say that the connection-oriented, it's quite that the connection with the specific agreed upon the parameters to be get established before the data is. So when I say the connection-oriented, well, I'm talking about the TCP. When I'm talking about the connection-less, it's called about like UDP. So connection oriented require the connection to be get set up based on the agreed on a certain parameter. So what does exactly it means that? So then that need to be have the client and server need to get exchange some packet before the packet delivery process is start. So it means like connection oriented with the specific to agreed on certain parameter means the client sets certain conditions and the port should be open and then the connection will start. So it's like if we have set up this meeting, so we agreed on certain parameter on what topic we are going to discuss, what is the time, how we are going to discuss. All those things that we have decided. Then only we are able to get communicate smoothly. So connectionless, they have no any information. Like before data send, we don't do the any setup. Directly it sends the data. That is called as a connectionless. So transport layer is responsible for deliver and manage one from one process to another process based on these conditions. Let's have understand how it will work. If we can see the TCP IP protocol suite interoperated with the two transport layer protocol, the transmission control protocol, the TCP and the UDP. TCP is the connection oriented, UDP is the connection less mechanisms. So when I talk about the connection oriented, the client and server must get extensive packets here. So the client is going to send some message, the server is going to agree that message, and then the connection will establish. Process is called as a three-way handshake. Now, if I talk about the UDP, there is no three-way handshake. They directly send the packet. What does it mean by the three-way handshake? Let's do understand. So when I say the three-way handshake, so is the process, is the method in the TCP/IP network to create a connection between the two hosts. As we can see that it's a three-step process that requires the both client and server must get exchanged the synchronized and acknowledged packet before the actual data communications is begin. So it means like whenever the client is going to set up a connection to the server, they need to exchange some packets. That is called as a synchronized and acknowledged packet before actual communication starts. Now, if you'll see that the client sends a synchronized data packet to the server whenever it wants to communicate. And the objective, if the packet is ready and the server is open for the new connection, then it is response to it. Let's have a look on this. This is the client. We are going to reach to the server and we are talking about TCP connection. So when we are sending the request is sent by the client to the server, the synchronized request. Now, if the client is willing to communicate back, it reply with the synchronize and acknowledge. Here, if we can see that if the server is willing to communicate to the client, if the port is open, it responds with an acknowledge packet here, as we can see that. And here, it also express intention of talking back to the client with the synchronized packet. Together with it is sent the synchronize and acknowledge packet. This is the acknowledge for the synchronize, willing to communicate back with the client. That's the reason it sent it along with the synchronized packet. Finally, client responds to this message with an acknowledge. When it is done, the connection setup is done. Upon the completion of this process, the host and server can get communicated. Now, let us see some more detail about it. Let's imagine a situation, guys. Client is going to communicate with the server. Correct? Yes, everyone. Now, if I say that the server port number where it is getting communicated is 442. What do you mean by this? What do you mean by the port number 443, guys?
So HTTPS.
Okay.
No, it's like okay.
Yes, please.
So the client requests to connect with the server. The client port is 443. When the
So
server,
the server port is 443, right?
It's the server port is 443. It means like you have correct. You have went to the right server.
Yeah. See, I'll tell you, as we know, like the in services. Like if I talk about example, let me give you one example to get you understand. If I'll say like HTTP, if I'll say that HTTPS, so if I'll say like this will work on the port number 80, which work on the port number 443. The same thing like FTP, which work on the port number 20 and 21. The same thing DSCP, we have discussed that in the previous session, which work on the port number 67 and 68, right? As we can see that, and so on. DNS work on the port number 53, right? Like this, there are the fixed port numbers are there. Client have the random number, server as a 443 here. So this is the port number where the handshake, the three-way handshake is happening. So HTTP is 443 is the protocol which can be considered for the HTTPS, right? Yes or no? Mistake is the
yes,
secure communication. So let me explain you something here. Let me just give you one idea about like how this will happen. Do you think like three-way handshake happens in UDP also? Any idea, guys? No, right?
No,
Why
bro,
so
we don't have it.
confused? Because it is a connectionless, na. It's a connectionless mechanism system, as we know very well about it. So here we can see that whenever I'm talking about it, there is there is not required any like excuse me, give me 1 minute. 1 minute, please. Let me just do that later. Okay, let's see that if it comes to the TCP here. Here we can see, guys. Let's have a look on this. What it says that we are talking about the three-way handshake here, right? So let me take the three-way handshake process here in the TCP. Okay, here we go ahead. So are you able to see this packet? I want you to see that client address is 192.168.0.6, where the client have the port number. We can see that as 50298. Is that client port number? Now it's going to connect to the server. The server is 8081131109, which is having the port number as 443. And this is the TCP connection. So it's sended the synchronized packet here. Correct? Is that clear, everybody?
Yes, bro.
yes,
Now, once the synchronize is sended, the server is going to reply with synchronize and acknowledge. As we can see that the server is 8081131109, which is having the port number as 443. To reply to the client, that is 192.168.0.6, with the port number of the client is 50298, and it says that the synchronize and acknowledge packet. So here we can see that the server is going to reply back to the client with then synchronize and acknowledge. And finally, as we can see that the client are going to acknowledge that packet 192.168.0.6 with the port number same as 50298, where it's going to send a request about the acknowledge here. 50982 to the 443 acknowledge is done. This is the process. It's called as the three-way handshake. Clear, everybody? Yes. Am I clear? Clear.
Yes, brother.
Now, what the next here? See, as we have seen that this is happens on the 443. So it means like they are going to send all the data in an encrypted form. So that will be certain algorithm, the security algorithm is required in order to encrypt this data here. So how does this data will be get encrypted? What type of the process is happen? So as you can see that after that we have something called as TLS version 1.2. Are you able to see that after three-way handshake is completed, suddenly we can see client has sent it 192.168.0.6 to the same message to the server. That is a client hello. Are you able to see this here? Everybody?
Yes, bro. The message was decrypted.
Yeah. So these messages sended that to inform that what type of the transport layer security is using it. This is nothing but the transport layer security. If I talk about it, the encryption format here, right? What type of encryptions they are using. So the client, whenever it is sending this message, the client hello to the server, it sends a message to the server because it contains the TLS version support. What type of version we are using? So the client says that I'm supporting the TLS version 1.2. It can be 1.3 also. And also it sends it about some detail in that we call as a ciphering suit. Ciphering suit are nothing but which is says that encryption algorithms the client may support. You got my point, everyone? Is it clear? What type of the encryptions will support by the client? So they send that, and also it send the client random numbers. So a random number used for the key generation, and also the session ID. So it resumes the previous sessions where we have stopped, and which have something called as a SNI number that will be considered as a server name and identification. Some are the details here. Let me explain to that. So if we can see that here, this is what I'm talking about it. It contains some information about the handshake protocol for the client hello for the TLS version. So it sent the information about this version. Along with that, it contains some detail here. So client hello, which contains the random number, as I said you that correct. It contains the session ID, right? This is the session ID where we can see that. Also, it contains the ciphering suit here. So what type of the ciphering suit are using it here? Are you able to see this here? This many ciphering
Yes.
suit can be get support. While the encryptions happens, this many differing support can be supported by the client here. These are the message which is sending to the server. The server is going to see that what is the server is getting connected. So the extension server is to the API meter, the ringcentral.com. Means like this is the applications where this is the IP address is belongs to. The server is belongs to here. Okay. So they have some of these detail here where we can see what are the support version can be there for TLS, TLS version 1.2, TLS version 1.3, 1.2, 1.1, 1.0. So support variations can be a different here. This is the extensions which have been containing the informations about what type of TLS version can be supported by these applications. Now, when we say that the client hello, then the server is going to respond to here. Can you see that here? 8081.131.109 is a server going to respond to this one. So server hello. We have seen the client hello, and we are seeing the server hello, correct?
Yes.
Now, what does it mean by the server hello here? So the similar way as we have seen the client have sent it those message, the server server is responding with the the client message what is sent it hello. So server hello is a response message to the client hello, which is selected the TLS version, which is highest manually supported by the client, and they select the ciphering suit which is sent it by the client, and also the random number in order to generate in key, and session ID to resume the same session, and the SIN number. We call as server digital session identification number. They have certain information that is required for this process. So in order to encrypt, require some TLS certification also will be taken here. If we can see that here on the server hello, if we'll see the information here, this is a real excellent. So here we can see says the server hello, which is taken the TLS version as 1.2 here, where we can see that server hello is contain the informations about it, random number which is sent by the client. Okay, the ciphering suit which is taken here. I've taken the session ID, everything which is are going to resume here. So server name, what is the server name, extension, what are they been using, applications, protocol, negotiations, everything. Overall, with the help of this process is going to be get encrypt the data, which is send it over here. You
I
got
have
my
a
point?
doubt. Sorry for interrupting.
Yeah, please.
Bro, cipher suits are used for encrypt the data.
Yes, they use a certain algorithms, right, while encrypting the data.
Okay, so there are many cipher suits, right? To
Yeah, it
encrypt the
depends
data.
upon the what. Yeah, it depends upon what they support. Got it?
Yes, bro.
Yeah. This is the process where we can see the three-way handshake is happening. Whenever we are seeing the three-way handshake, the client is send the synchronized packet to the server. Synchronize and acknowledge. And finally, the client send an synchronized packet to the server. With the help of this, the three-way handshake process will get completed. The client and server can establish the connections and they can be able to get communicate here. Okay. Now, if I'll talk about the packet section. The packet section is consists of three main sections. That is an IP header, TCP header, and we can see the payload here. This is the packet section where we can see that IP header, TCP header, and the payload. So if I'll talk about the IP header, which is content, version, header length, type of services, total length, identification, flags, fragments, time to leave, protocol type, source address, destination address, source port, destination port, sequence number, acknowledge number. We can see the different type of the TCP flags are there. This can be urgent, acknowledge, push, reset, synchronize, and finish. And finally, we can say the payload here. What are those important informations can be contained with these layers here? We can see the source IP, destination IP, source port, destination port, and then we have the TCP flags, which we have said here. The synchronize, acknowledge, packet, all those can be considered as a TCP flags. Then we have something called as a main data here. Data will be main sources of the packet, the payload which have been getting transmitted. So if you'll see that in detail, as we have seen this Wireshark here, right? Now let me explain you that over the Wireshark how it will be happen. I'll take one random packet here for the data. So here we can see that how this communications happens, what are things this happens over here. So let's do understand. So here we can see that first I'll talk about here if I'm saying that if I'm talking about the IP header, where we find the IP header, guys? Can you tell me that on which layer? I request you to respond on which layer the IP header will be there. TCP header or IP header? Network header? Which layer? Network layer or the transport layer? IP header will be there on which layer? Network layer.
Transport.
Network layer, right?
Yeah,
IP.
network layer.
IP is been allocating by the network layer, correct?
Yes.
So here we can see that this is my network layer. Can I say the internet layer? Is that okay?
Yeah, that's okay.
So here we can see that if I talk about the first most important thing is that where you can be able to see the version. Version is nothing but it says that IP version we are using, IP version 4 or the IP version 6 here. So we can see that here we are using the IP version 4 here. Now here we can see the header length which is of 20 bytes, which can be said to the size of the header, which is always fixed. Whenever we are using the IP version 4, the 20 bytes is always the size of these header. Will never get changed. Now, if I'm using the IP version 6, it might go up to the 60 bytes. Then we have the type of services, like quality of services, what services we are using. So they differentiate the the service type here. Then we have the total length. Total length is nothing but which consists about the TCP header, IP header, and the payload. All that includes can be considered as a total length. Let me make it more easy for you to get understand it. So guys, imagine a situation. We are sending one packet here, right? So let's say that we have transport layer. Let's imagine. So transport layer are going to receive packet, right? So here what we have our payload. Payload can be considered as the data here, right? So that is the data. The transport layer will decide the transport protocol. Right? Either it can be the TCP or UDP, right or not, everyone? Am I correct? So if it taken as a TCP here, if it is taken as a TCP, where we can see that this data has been sent as a TCP from this layer, where the data is going, guys. After this, which layer will come? Network layer, correct or not? So the packet what we have sent it here, this packet will come to the network layer, right? Here. Now what the network layer will do? Network layer will add it another header. It will be considered which header here? It's called as IP header. Yes or no? Am I correct,
Yes.
everyone? So
Yeah,
this
you're
is the
correct.
IP header. This is the IP header. So this is called as the total length. This is called as the total length, which is make it varies here based on whatever we are sending it. Based on that, it will vary because payload will be not in the same site also. Here we can see that when I'm saying that here we have the total length. The total length is the 40 bytes. It might be anything. If I'll see some other random packet, if I'll select the size may get changed. You see this here, everyone? Yes, right or not? Now here after that we can see that identification. Identification number. What do you mean by the identification number? Generally, what we call as the identification number, because whenever we are sending any packet, right? Whenever we are sending any packet, how this identification number will be there? It decided which is the best, which is the best process which we need to be get connected here. Like what is the best packet are there to be get combined here? So here we can see whenever we are talking about the identification number is used to find out identifications for any packet what we are sending in for the purpose of reassembly. So let me make it more clear about that. Okay. Now imagine a situation, guys. This is our endpoint. Okay. I'm sending one packet, so I have the router. Let me see that some other router also is there. And there is some other endpoint also there. Let me just copy this. So this is the end user. Let us consider who going to receive the packet here. So let us consider that. Here we can see that there is some router we have it here, right? Now, while I'm sending this packet, so the router might contain certain size of this packet. We call something called as a MTU. You know about MTU? Have you heard anything about the MTU, guys? Anyone here? MTU is something that we call as a maximum transmission unit. So it designed like what is the largest packet that can be get sent it. What are the exceed can be happens here. So which is already defined here. Because whenever we are sending the packet, what exactly the identification number will say that whenever we are fragment this packet, identification number will be there to identify that packet belongs to the particular station here. Let's imagine that MPU size is to get you understand a better way. Let me make it varies based on the next component. I'm saying that 500 bytes. While I'm sending, this is just example. Now here I'm sending 1500 bytes. Now do you think like transmit this packet? Is that possible, guys?
Might be it will be divided into three parts, three parts.
Yeah, but anyhow, if we are sending this 1500 bytes, it won't be able to transfer. Correct? Yes.
Yeah, in a one. Yeah.
So for that, here we have segmented. What does it mean by that? Let's understand that. We have like the identification number, let's say that as 1234 example. We are sending the packet A, which is of 500, which I want to know that. So we are sending this packet as a 500 bytes here. Like you can consider that. The same way we have another packet of the same. This is a packet B, and the same thing we can see that another packet we have it like that is considered as packet C here. So overall, what we got to know that here. So with the help of this, we can understand that the identification is the number which tells that these stations are belongs to these packet are belongs to the particular station here. Correct? You got my point, everybody? Is that clear?
Yes, bro.
So here we can see that this is what we have identification numbers. We have the time to leave. We have the protocol type. We have either checksums. Now protocol type is 6 here, right? You can see that. So TCP 6 is shows that. So when I talk about similar way, if I'm talking about the UDP, so it says the 17 here. When I'm talking about the UDP, it's called as the 17. When I'm saying the TCP, it's showing that 6 here. So what is that? Never get confused because while we're working also, let's say that an example, we are working on the live environment. Sometimes we'll get the traffic something like this here. Let me just give you one idea about this. So I have one use case here to my M2. So let me just give one idea. Are you able to see something here, guys? We have some numbers like 6, 17, and 1, right?
Yes, bro.
Now, when we can do this analysis, if I'm doing certain analysis on these packets here, as I can see that this is the 6 traffic, this is as a UDP traffic, right? 17 as a UDP traffic. Is
Yes.
Yes.
where I can
Pink.
see that pink color is been considered as a more as 91% that will be as a UDP, and this is can be considered as CP. Now, how we can say that? Because I'll tell you something about it. When I say that TCP, let me just give you one example. So here we can go ahead with, then you can see that we have something like ICMP, Internet Control Message, IDMC, like, version, something like that. If I'll say the 6 is a TCP, right? This is a protocol number. It's just a, the sequence number, what is done by the INA here. So you don't worry about it. The port
Okay,
number is
that's a serial
different.
number.
Yeah, that's the serial number. So I don't want you to get confused with the port numbers and the protocol numbers are different. Okay. The port numbers are different. The protocol numbers are different. You got my point? Clear, everyone? So,
Yes.
This is six is nothing but not a protocol number or a port number, now, brother.
yeah, it's a protocol number. It's not a port number.
Okay, I got you.
So
Protocol.
TCP 6, UDP 17. Sometimes we are doing the analysis, like, let's see that if I'm doing certain analysis here, we got it 1, 6, 17. So what does it mean by that? No, we have the other field also here. I can show you that field also. So if I'll say that, it shows the clearly about that. Sometimes might be, we need to have an idea why these numbers are there, right? ICMP is 1, UDP is 17, TCP is 6, correct? You got my point, everybody?
Yeah. Yeah.
So the analysis may do based on these processes also. So we must know something. What does it mean by this? Why it is showing as a protocol number 6 here? So when I talk about the same thing as a UDP, then it says like 17. But it might be in future coming any numbers you get understand now. The protocols is contain the certain port numbers and protocol numbers through which we can understand what service is carrying on. Right? Correct, everyone?
Yes, bro.
Now here we have some checksums which can be validate the data. And here we have the sender IP address and the receiver IP address. Source address is nothing but always will be considered as a sender IP address. And destination address is nothing but as a receiver who are going to receive. These are the informations where we can be able to see at the network layer. So we have sender IP address and recipient IP address. Now this is the way where the communications happen. Now if I talk about, there's another header, right? So this is all about the IP header. Now there is a something called as a, whenever we are talking about this, we have a transmission control protocol. This is the part of which layer, guys? Can you tell me that?
TCP 6
No. Which layer? OSA layer.
or layer. I think network layer.
No. Just now we have seen the network layer.
Data. That should be data.
No.
Transport.
See, the transport layer to the network layer, it will go now. Right or not? So means like the TCP or UDP traffic will be decided by which layer? Obviously, it will be divided by our TCP transport layer only, na? Correct?
Yes.
So this is a part of the transport layer which is contain all the service, all the ports. You got my point? So how it is that, guys? See, simple way. This is a network layer, transport layer, network layer, and data link layer, right? Correct or not? You got my point, everybody?
Mm.
See, in a practical scenario, I have said that there is an application layer which is compressed with presentation layer and session layer, right?
Yes.
So this can be considered your browser. As if now just I want to see you. I want you to understand. This is a browser, right? Yes or no?
Yes.
Now after that layer, after this application layer, what is the next layer? After this layer, which layer we have it?
Network layer, I guess.
No.
Presentation layer.
See, this layer is also contained. If I'll say you that it is also contained, there are two layers, right? Application layer is complete with the presentation layer and
Session layer. Session layer.
session layer. So it's like this all together. Can I say that one as an application layer? Correct.
Yes.
This layer, after this layer, which have means like when I talk about it, this is the seventh layer. Application is the seventh layer. presentation layer is a sixth layer and session layer is a fifth layer, right?
Yes.
Now, what is the fourth layer?
Transport layer.
Transportation layer.
Transport. Transport
Transport
layer is the fourth layer.
Transport layer. Then we have, like, what is the third layer?
Network
The
layer.
network layer.
Network
Network
layer,
layer.
right? Then we have the fourth layer. Sorry,
That's
second
a
layer,
that's
data link
a
layer,
that's a
Data
link
link
layer.
layer.
which is compressed with the physical layer, correct? Yes or no?
Yes.
Yeah.
Overall, if I just for understanding, like, when I say that if it not there also is the same thing, na? Which is the application layer is compressed with the presentation and session layer. So we have this four layer, correct? You got my point, everybody?
Yes.
Now, if you see that the transport layer, network layer, the data link layer. First, we have the application layer, correct? So my
Yes.
browser can be considered as an application layer.
Yes.
Now, what would be the next layer here? Transport layer.
Transport layer.
So this is the transport layer. You got my point?
Okay,
Yes.
TCP.
Yes. Then we have the next layer, network layer, right? This is the network
Yes.
layer, internet layer. You got it now? And then data link layer. So this is the data link layer, ether address, which is contain the MAC address here for the communication. I believe you got my point, correct?
Yes.
Yes.
So when we are talking about this is as, so while I'm talking about this is as a transport layer, okay? So the transport layer, what is contained here? So as we can see that whenever we are talking about the transport layer, the first thing is contain the source port. The source ports identify the senders. What is the senders applications are there? What requests we are sending it? So what is like, the sender port numbers are there? Those will be sending it here. So the port numbers are 0 to 65,535 port numbers are there. So in that, there are the most common port are there, 0 to 1023 port numbers are there. So that might be any random number can be get range here. So if I'll say that there are the several numbers are there for the port, which can be decided by the sender and recipient. The server is as a fixed 443 HTTPS. It can be considered as a receiver service, and this is the sender. Everybody is that so clear? You got my point?
Yes, the sender port always change.
See, sender port means like it depends on the service type, na? See, if you have initiate one service, so you will be got one port. So that till that session is complete, that same port will be there. It's a random port only. But once the
Random
service,
port.
when you end the service and you again initiate, again you'll get some random port. But the server didn't have the fixed port.
Fix.
Okay. So I mean to say that I'll talk about the port numbers in detail. Don't worry about it. Okay. I will explain you about that. While I'm coming to the protocols section, right? I will explain you in detail about those port numbers. Got it?
Okay.
So here we can see that the sender and receiver port number. Then comes a very important thing is that which you have to see the sequence number. Now, what exactly it is meant by the sequence number? So it's track all the bytes that is have been sending in order. So the sequence number is reassembling all the packets which have been coming in. So the initial sequence number which have been chosen by one we send it the three-way handshake, right? So there is a initial sequence number has been randomly chosen while we have completed that, and they send the number of bytes here. So when we talk about the acknowledge, the sequence number is for tracking that and acknowledge what we are received here. Inform the received data whenever we are seeing the flag as an acknowledge. So acknowledge numbers are nothing but which says that what is the packet I've received and what would be the next packet I have expected here. You got my point, everybody?
So here's a brother here when we send the packet there that time we got the sequence number like 81.
Yes.
Then is coming the next when the receiver reply back that one, then we got the 82.
See, it is not that like the sequence. It means like what are the packets we are sending it. So the sequence number is generated by the once the three-way handshake is sent. So it says that I have sent you this packet and it is given acknowledged number. Got my point?
Yes, I got it.
So if you can see that it's not a serial number, if you can see these numbers is are completely different. It's not matches with each other, right?
Yes.
You got my point?
So if any data or packet lost, how do you know if the sequence number is not matching?
See, when the it is for that for identification number are there na for data loss.
Okay.
Reassemble the packet, we have the identification number. But when here, if we talk about the sequence number and acknowledged number, the number which is sent, it not received, so it will say that not acknowledged. Then it will be retransmit the data. You got it, my point?
So the acknowledgement number is nothing but confirmation number, right?
Confirmation number. Yes, got it.
Yes.
Yep.
Yes.
Yeah. So that's how it send the sequence numbers and acknowledge number to confirm the received data where we can say that acknowledge here. So we have some other parameters which is important here. Now we talk about the TCP flag. TCP flags are nothing but there are the several flags are there, like we have urgent, acknowledgement, push, reset, synchronize, finish. We can see that those are the flags mostly used. So when I say that the acknowledge, as we can see that it indicate the acknowledgement, whatever we have received. Urgent, it marks the data for high priority. Use the higher pointers that need to be sent. Reset, if anything happens, if any connection is getting down, so they can reset. Acknowledge, synchronize, initiation, right? We have seen that initiate a three-way handshake. So it sends the synchronized packet and then the connection established. Finish is nothing but we are giving the connection termination request. So gracefully we have completed our process. Now we want to close the connection. So the TCP go with the flag as call as finished here. You got it, everybody? Is that clear?
Yes, brother. Brother,
Yeah.
what is the window size 257?
The window size 257, which is says that what is the receiver buffers are there? It talks about the receiving buffers. Whenever we are talking about it, that the receiving buffers can be there. Overall, it is used for flow control. So whenever prevent the sender from overlapping the receivers, right? So how those data can be get scale here? So can be scale using this window scaling options that will tell us how the data can be comes here. So they calculate it and based on that they can receive those data here. Okay.
So if the buffer cast the buffer cast is high, that time we can get the network is slow or like that something.
No. This is all about the overlapping the data receiving. So whenever the prevent the sender from overlapping the receiver data, right? So for that purpose is do the flow control here. So that will be scale with the different options. Based on that, the data can be get sent here. Okay.
Okay.
So this is how it works, guys. This is some of the major factor. In fact, if I'll tell you that while doing the analysis, is that we need to be get understand more things on this? No. As you know, very well, these are the points more enough for us. You understood carefully about the source IP, destination IP, source port, destination port, TCP flag, and the data. That's the good enough for you to get understand what are the transport protocols are there. How does the public IP, private IP can be get differentiate? What number of type of ports? What type of services we carry? Because those are the informations required while been working as a security specialist. Because our aim is not to become a network administrator. We are the security guys, right? So get you understand how the network works. That's the reason where we are doing it these sessions. And in most of stations, to be frank, I'll tell you, most of the batches I don't start with networking. I'll directly start with the security. I'll give them a video for the networking to have a review if you're not good at the networking. But some batches where I'll go ahead and discuss some of the concept on networking. So one of your batches I'm going to discuss this networking concept. Got it?
Yeah.
Okay. So main target is about the security. So we're going to discuss that in more detail about it. Okay. Now if I talk about the TCP flags, so there are the 6 flags will be there. You can see that. So these flags can be like present, synchronize, finish, reset, and the post here. Synchronize, it says that it is used for the first step connection establishment before the three-way handshake is taken place. That's how it will be done as a synchronous. So initiate request from the client to the server, it's going with the synchronized packet. Acknowledge, it is used to acknowledge the packet received successfully by the sender here, like who have sender that have received by the receiver here. That's how we can see that. Now finish, it is used to request the connection terminations. Like, whenever we want to stop the data, we have sent it all the data. So it comes with the finish. Reset. So I want you to just have a look on this, guys. Before I go ahead further here. Are you able to see this, all the packet here?
Yeah.
Acknowledge, push. Can you see that push here? PSH.
Yes.
So all the TCP packet will go something like this. Here we can see the reset. Yes. Correct. Everyone. So here we can see that the flag comes with reset. So what type of data, what type of information they get exchanged, all those can be there. So we can see the reset also. To terminate the connections, if the reset sent, something is going wrong with the TCP connection. So it is like conversation should be not exit, it should be get reset here. That is happens. Push, it's tell the receiver to push the data packet with the more intent instead of buffering them. And urgent, the data integrated segment with the urgent side one comes, that will be forward data immediately to the applications if it is required. It also allocate more data to it. This is how the urgent can be. Is that so clear, everybody? Do you got it, my point? Yes.
Yes, yes.
So this is all about some basic part. We have some more discussions on the networking. One more session. We'll discuss some more detail, and then we'll start the security sessions. All right.
Thank you.
Yes, you're welcome. So see you tomorrow, guys. Thank you very much. I believe all the videos are uploaded, so you can just click and watch. So after when we get very soon, it's been going to get into the private. I request everyone, those are there in the WhatsApp group, please kindly send your email accounts, email IDs in the WhatsApp. Make sure that you should have only the Gmail one. If you have Yahoo, Hotmail, so create one Gmail and send it there, because all the video access happens with the Gmail account only. Got it? Yeah. So thank you. Thank you, everyone. See you tomorrow. Take care. Bye.
Okay, thank you.
Good night.
Thank you, bro. You too. Bye.
Bye.